Okay, welcome everyone. Welcome live. I am your host Matt. Welcome to the Embedded Rust class by Professor Brad. So I'll be going off now and giving Professor Brad the chance to give us what Embedded Rust class will be having for us, and then welcome to the first class in the 4-week series. Thank you very much.
Thank you all. It's great to see you. Hi, I'm Bart Massey, and I'm excited today to teach you some embedded Rust. I couldn't be more excited, honestly. This is the start of a journey, and it's the start of sort of an experiment in the sense that I've never tried to teach this many people remotely before, and especially from a very mixed group of people that are from all different places and with all different backgrounds. But I think we can make this work, and I'm very, very excited to give it a try. Let me mention as we start, paste it in here somewhere in the studio chat or in the chat, I think, is a link to a GitHub, which is where I'll be working from for this course. Let's take a look at what we're doing here. That thing has a bunch of the links that we'll need. Let's go to the course outline and talk for a second about that. So this is a 8-week course. We will have today some basic stuff about Rust, and then on Wednesday we'll do some more Rust. Then we'll have a week off while I attend the Rust Global Conference in China, and after that we'll start in really with embedded. So I'm imagining that some of you know some Rust. I'm imagining that all of you know how to program a computer in some programming language. That's probably necessary, but you don't really have to know much or even any Rust to start with this course, but you do need to learn a lot of Rust very quickly. Let's talk a little bit about all of that. Yeah, so also, you may not know anything about embedded hardware. I expect most of you won't, and that's fine. But if you do, it'll be helpful. Doesn't matter. I should tell you a little bit about myself. I'm Bart Massey. I'm a professor of computer science at Portland State for the past 26 years in Portland, Oregon in the USA. I did my graduate work at University of Oregon. I have a master's in programming language implementation and a doctorate in artificial intelligence, but not that kind. I started doing embedded in the 1970s when it was kind of a new thing, and have been doing it ever since, off and on. I spent a couple of years out at Tektronix here in Oregon doing embedded development for television measurement products a while ago. And I started doing Rust about soon after Rust 1.0, like 9 or 10 years ago. So what are the tools to have to kickstart with Rust? We'll talk about that. That's a great question, and we'll talk about that in a second. The basics here are going to be looking at the Rust programming language book and getting Rust installed, and I'll talk about both of those things here just very shortly. One thing that didn't make it into the slides, so I'll fix it now, is I wanted to thank some people. I wanted to thank Rust Africa, first of all, and Mordecai and the gang for setting this up and making it possible. The work that's been done to make this a thing is really, really amazing. I want to thank FutureWay, which has provided me with funding that makes this course possible by giving me release time. I wanted to thank the Rust Embedded working group that is, the people who are the sort of focal point for Rust Embedded. I'm fortunate enough to be a member of that working group and have gotten to help them with some stuff, and that's great. Dang it, that's not supposed to happen. My apologies. Let's kill that so it can't happen again. And I knew I forgot something today. And I also want to thank Portland State, my employer, who has given me all kinds of time and stuff to do this. Anyway, how to get the most out of the course? Yeah, look, here's the deal with this course. I could have recorded these as lectures so that you could play them at your leisure. It would have been a completely one-way street. I wouldn't have, and that if we'd wanted to do that, it would have been fine. But the reason that we're doing it this way is because I want it to be a two-way street. I want you to talk to me and tell me what you need to know. Tell me if I'm going too fast. Tell me if I'm going too slow. I need you during the course to have a conversation with me, because that's what'll be fun. And outside the course, I need you to try out stuff. Get Rust installed on something and try it out. Get Rust Embedded installed on something and try it out. You really need to play with stuff so that you can come back next time with questions from what you've done. I'll also talk about some places in a minute that you can actually go to chat with me between classes, because I'm not just here to lecture. I'm here to also help out in general. So let's actually do that. That's probably a good thing to say. So the quick start of the language is this. Let's just do this. Let's just do this thing. Let's go to rustup.rs. So one moment, please. So rustup.rs, I hope that's big enough to read for everybody, is where you go to install Rust. If you haven't installed Rust yet, that should be your project for the day, is to get Rust installed and up and running. And what you'll get when you go to this place is some instructions about how to install Rust, and it will install the Rust installer, RustUp. RustUp is an amazing tool and is the preferred way to have Rust on your computer. This will work fine for Windows, Mac, or Linux. I am a Linux guy, and I'm going to be demonstrating everything using Linux just because that's what I know. Mac will be pretty similar. Windows will be somewhat similar. I don't think there will be huge differences, but if you have a problem, then we can talk about that that's specific to your platform. So you first do this thing and install Rust. And then the book that I recommend for absolute beginners to Rust is the Rust programming language. And that's the book we're going to kind of follow for these first two lectures. The Rust programming language is, again, freely available online. You can read it in a web browser. You can download it as an ebook. You can download it as, you can buy it as a paperback book, but I just read it online. And it's a pretty good introduction to the Rust programming language. I think it's quite a good way to start with Rust. And so what I would suggest, to answer your question from a bit ago, is get Rust installed on your machine as quick as you can. You can do it during this or right after it, and then go through this book and learn what's in it. And we're going to go kind of along with it today once we get going. So there's that. I mentioned I'm the founder and current director of a thing called rustedu.org. And this link here, zulip.rustedu.org, is a link that is absolutely a place you can go to chat. I've set up a channel there, Rust Africa Embedded. Zulip's kind of a weird chat program, but it's the one we use. So the point is you can find me there anytime, and I'll try to answer your questions and help you as you get started. Yeah, I think that's the stuff we need to talk about from here today. So yeah, one more thing, and then we'll get going with the actual Rust. Unless people, I'm not sure I'm seeing the actual chat. I've got something that says private chat, but what I really want is the chat. I don't quite know how to do that. Give me a minute here. Try to figure stuff out. Oh, there we go.
Okay.
All right, I found it. Sorry, it took me a second. I'm just bad at StreamYard at this point. This is showing up mirrored. Is this text mirrored or is it not mirrored? Can you read this screen right now?
Yeah, I can. Everything is clear. I can read the screen.
Okay, all good. All right, cool. Sorry, I just wanted to make sure we weren't talking and couldn't read stuff. All right, so we've got now I've found the actual chat. That's good. Please, ask questions in the chat. I'm absolutely excited about this. No, the chat isn't the only way to ask questions. That Zulip link is the other one. I'll try to watch the chat real careful as we go. So let's go back here. We'll go for 45 minutes or so. Then we'll take a little break in the middle somewhere so that people can go get coffee, use the restroom, and reset their brains. Yeah, so that's what we're doing today. So let's actually go back to the course outline. Let's see. So once you've installed Rust, what do you got? Well, you've got a tool, rustc. Rustc is this font big enough too? Also, please let me know if it's too small. Rustc is the Rust compiler, and it's a very nice Rust compiler. We almost never use the Rust compiler directly. It's really unusual to do that. What we normally do is we use a tool called Cargo, and Cargo is the build tool for Rust, and it's kind of one of the things that makes Rust an amazing programming language. So let's make a little thing here. So I'm going to make a new project with Cargo, and you do that with just Cargo new. I said --bin to make it a program rather than a library. And the program we're making is called Rust Basics. And if you'll notice that when Cargo makes a new directory for code, it makes a file called cargo.toml. And the cargo.toml describes, is the setup file essentially for Cargo. And it also makes for us a default main. So this is a program. This is absolutely the normal Rust program. And it's a tradition since Kernighan and Ritchie to print hello world in some form. Fun here says we're declaring a function. Main is the name of the function. The function takes no arguments and returns no value. That's not quite true, but it's close enough. And println here is print with a new line, and it also has an exclamation point. That exclamation point means that it's a macro. We don't need to worry about that now, but we'll talk about it later. And then this thing is just a string like in any programming language. Rust uses semicolon as a terminator. And this string, hello world, is just what you think it is. So the point is that with all this, if I say cargo run, Cargo will look for a source/main.rs. It will build it, and then it will run it for us. So let's do that. And look, it prints hello world. We are now programming in Rust. Well, so far Cargo's programming in Rust for us, but that's a thing too. We could have just said Cargo build, and that would have just built it without running it. Rust programs are ordinary binary programs like you'd get out of any compiled programming language. If you look in target, debug, and our program name, Rust Basics, that is actually an executable program produced by the Rust compiler that does what we wanted it to do. And I can run that directly if I want to. It absolutely works fine. I can move that around and stuff. It's what's called statically linked, meaning that other than libc here and a few other small things, mostly there's no dynamic libraries. For people who know what that is, this program is pretty portable. I can carry it to a lot of other Linux machines and have it work. Rust is very cross-platform. It doesn't care. I could compile this program for Windows pretty easily. I could compile it for Mac pretty easily from my Linux box. And that's important because later we will be absolutely cross-compiling for our Magic hardware. Let me show you our Magic hardware quickly since we're running, since it's lying around. It'll be a nice thing to do. Let's see. This should work. So this is the BBC Microbit version 2. Yeah, I believe that it is being recorded. This is the BBC Microbit version 2. It's a little Rust embedded board. A little embedded board made by the British Broadcasting Corporation as an educational tool. Some of you will have these already. Some of you will get them later. Without them, you can follow along with the course, but if you want to actually try stuff out, you're going to need one of these. This is sort of the official board for this course. It's not a super cheap board. It's $20 US or so. But it's, and probably more if you buy it from somewhere, other than the US. I don't know how much it is, but it's small enough and cheap enough that you can, sort of bang around with it and learn how it works. So this little computer, you can see on the back is the actual computer part and a speaker and another computer and a whole bunch of hardware. We'll learn about all this hardware in the course of this course. And so, yeah, we'll have to compile. This thing's way too small to run a compiler itself. So we'll have to compile stuff on our computer for this computer. And that is part of the fun. So going back to what we were doing. The other thing you should know is that by default, Cargo compiles things for debugging, which means that the binaries are big and very slow compared to what you should. If you want it to go at a reasonable speed, you can build with the release flag. And that should have been the default, but we made a mistake when we were creating Rust, and it's not the default. So I would recommend that you normally always use, unless you're actually planning to do debugging, you normally always use -- release when you do stuff. And so let's actually learn some Rust by playing with this program that Cargo built for us. We will come back to the microcontrollers in a class or two, but for now, I think we're just going to work through some Rust and talk about it. So So here's a function. It's absolutely boring, but it does a thing. Let me see. Let me go. There we go. Obviously, Rust has strings. Rust strings are a little weird, and I'll talk more about that at some point probably, but for now it doesn't matter very much because we're going to be doing embedded programming. It also has numbers, as you would expect. So this kind of thing will work too. Oh, I remember what I was going to tell you about setting up that I didn't tell you yet. I'm using Emacs, which is a text editor, and it's an ancient, terrible text editor, but it's what I'm comfortable with. So I wouldn't recommend that. What I would recommend for you, if you're getting started for editing your Rust programs, is that you use Visual Studio Code, Microsoft's Visual Studio Code. You can get that again for Mac, Windows, Linux, and it'll give you an IDE interface that's very nice. Sure, why not? Did not mean to do that, but okay. And let's go back here. And one of the things you should do when you do that is that you should look for Rust Analyzer. And you should install Rust Analyzer. It's absolutely the standard tool to use with Rust in Visual Studio, and you'll be really, really glad that you have it because it helps you edit your Rust as you go. You may also want to install Git support and that kind of stuff. VS Code's an excellent tool. There's plenty of tutorials on YouTube and other places about how to use it with Rust. And I'm not going to teach it here because I don't use it very much, but that's probably what most of you will want to use. There's other choices. JetBrains has excellent IDEs and other tools. And there are other things around. But the point is, sorry about Emacs, but that's where that's where I kind of live. So I'm just going to live there. Sorry, let me get out of this stuff. Okay, let's just close Rust Analyzer. This is dumb. Close VS Code. All right. So meanwhile, back in the world of Emacs, if I run this, I get 5, which is kind of what you expected. Rust's integer types are interesting because there's a whole bunch of them. There's, Rust Rover's good, 100%. Sea Lion is, or whatever it is from JetBrains, is also pretty good, but I think they're really encouraging everybody to use Rust Rover. Yeah, the other one is Zed. If you have a Windows box, I believe it currently only runs on Windows well, but Zed is a Rust IDE written in Rust, which is pretty good. Rust's data is Rust integers have types. There's sort of two kinds of integers. There's signed and unsigned integers. If I say 3 minus 4 here, I'll get minus 1 as you expect. But I can actually say what type a number is. In this case, I'm making the number be U8, which is unsigned 8-bit integers. Do I need to talk about Oh, right. This is a difference from Python, which uses similar formatting, which is that because of the way Rust works, you have to put these expressions over here. Another way to get it that would work in modern Rust is this will work as long as you can put a name inside the curly brackets, but you can't put an expression inside the curly brackets. It's super annoying. And so I usually just write things this way. Oh, but as long as we're here, let's leave it this way. Let's compile it and make sure it still says -1. Oh, interesting. See, now, because I said this is unsigned, well, unsigned means that the number can be 0 or bigger. It can't be negative. Notice who noticed. Notice that this is not a runtime error. This didn't try to compile the code and then run it and then have it report a mistake. The compiler actually noticed that I was trying to, at compile time, that I was trying to do a smaller number from a bigger one and a bigger number from a smaller one. And so it's like, no, that will never work. You can't even. If I tell the compiler, no, we're gonna make it do this, then not having this, so it's gonna be okay. Then the compiler will go ahead and do it, and we'll get a panic. Notice that this is a runtime error message now, and it says, "Oh no! You tried to subtract and it overflowed." And so in safe Rust, you can't ever have the program go wrong in some horrible way. But in this case, it's more than that. It's a special check. Let's see what happens if we cargo run -- release here. Oh, shoot. It came and ran, and it let it overflow. Another mistake that was made in the early design of Rust is that it checks for overflows in debug mode, but not in release mode. You can turn that check on for optimized compilations, but you have to turn it on special. But the good news is that it didn't like crash or do some weird thing. It just let the arithmetic wrap around. So who needs a reminder about how bits work in bit arithmetic? Anybody? Okay, then I will just assume that people know that 8 bits means, U8 is a thing that can hold a number between 0 and 255, and U16 is an integer that can hold any number between 0 and 65,536. Yeah. Oh, okay. There we go. There's a yes, please, I do. All right. So let's do it this way. Here's some Rust comments. Oh no, let's just do this in a separate file. A number in a computer is pretty much always represented using the bits of the computer. A bit is a thing that can be a value that can be either 0 or 1. It's a charge or not a charge inside the computer somewhere of electricity. And so if I go let's say that this is a position. So memory consists of a whole bunch of boxes, and each box can hold a number, hold a value, and the values are really 8 bits, each one of them. So in here somewhere is some number like 17, let's say, sitting in here. But how is that 17 represented? Really, that box is an 8-bit byte, and so it's a number. It's not a number; it's a bunch of switches. And the way we do that is we say that the value of these positions, of each of these positions, is 2 to the power of the position. So position 0 is worth 1 because 2 to the 0 is 1. Position 1 is worth 2 because 2 to the 1 is 2. Position 2 is worth 4, and so forth. And so these grow: 8, 16, 32, 64, 128, and that should be all 8 of them. Yep. And so here, if I want to represent 17, I turn on the 2 to the 4th bit, which is this one, and I turn on one more, and so now I get 16 plus 1 is 17. Yeah? All clear? And so if you work through all the possibilities, all the possible combinations of these, you find out that they make numbers between 0, when they're all 0, through 255, when they're all 1. And that's a thing. Now, we also have signed numbers, because sometimes you want to be able to have negative numbers. And those are represented using a very similar scheme, except different, where this high order bit is treated as a sign bit, and then the rest of the bits are done in where it's 1 if it's negative, 0 if it's positive, and it's done in 2's complement. And we don't really need to worry about the details of 2's complement here. You can go look it up when you're interested in it. But it's a way to represent negative numbers, and that will let us represent minus 128 through 127 if it's a signed number. Now that's an 8-bit number. That number fits in 1 byte of memory. But sometimes you want to be able to deal with bigger numbers. So going back to our computer program, I'm going to do this. Put this back and just comment it out. Tremendous what we've done. Here we have a U16. That is an unsigned 16-bit number. And that does the same binary numbering scheme, but it fits in 2 bytes and can hold a number up to between 0 and 65,536. Rust also has U32, which can hold a number up to 4 billion or so. It also has U64, which can hold a number up to 16 billion or so. And then it has U128, which, again, you almost never use U128s. They're a weird type. But U64 is sort of the natural type of big computers. Big computers typically have special internal memory that's 64 bits wide, like this one I'm running on now. Our little microbit has 32-bit special internal memory registers. And so these are kind of natural sizes to use. The default, if I don't say in Rust, is I32. It turns out, just because it is. But that default almost never is a factor for reasons we'll talk about in a bit. The other thing I should say about Rust is that it's very strict about types. This will fail to compile because you can't subtract two different types or operate. The operations don't work with two different data types. I have to cast one of these to the other. In this case, I can say as U32 and then it'll work. But it's something to watch out for, is that Rust checks a lot of things at compile time. The reason it does that is to keep you from making mistakes. But let's talk a little bit about what we've done here. X here is a variable. This is how we make variables in Rust, is with the let statement, which is different again than in most other programming languages. This makes a new variable called X. If I try to assign to that variable, I'm going to get a compile time error. Cannot assign twice to immutable variable X. And this is a good example of Rust's error messages, which are kind of best in the business error messages. It says, you know what? You're not allowed to do that. Well, why am I not allowed to do that? In every other programming language I've ever used, you can assign values to variables. It says, well, because by default, you're just not allowed to assign to variables. You have to say it's allowed. And the way you say it's allowed, well, how do you say it's allowed? It says, oh, fix it like this. So not only is it giving you an error message, it's suggested a correction to your program. And that's very much a Rust thing. And it's also very much a mild trap. You should make sure you understand what correction the compiler is suggesting, because it's just guessing and it's not that smart. But in this case, it is definitely guessed correctly. This is clearly the right answer. And so now I should get 2 as the output. And sure enough, this is a good time to introduce some other tools that you should know about. One of those is Cargo Clippy. Clippy is a bad joke based on an old Microsoft program that's become a meme. But the point of Clippy is to be what's called a linter. It's supposed to check your program even more than the compiler does and warn you about things that seem bad. Here, when I run Clippy, it's like, you could have written this other way. And sure enough, it's right. This is the same as C and Python. Both have plus equals operators. We have them in Rust too. And Clippy's like, yeah, you would normally write that with a plus equals operator. Clippy is a very useful tool, and I strongly suggest you fix not only all the compiler warnings in your programs, but all the Clippy warnings as well. Let's see if Clippy's happy now. It is. The other tool that you should know about is Rust format. And that checks to see if your program is formatted in the official Rust formatting style. Turns out in this case it is. But if I, for example, used a different brace style, like some people do, Cargo format would be like, nah. And if you ask it to fix it, it'll go ahead and fix it for you to be the official Rust style. Clippy, yeah, it's yes. Clippy and Rust format will be installed when you install Rust. They're absolutely default tools that are always available. So Cargo format is good now. Cargo Clippy is good, and so we're ready to go on. The official Rust format is not everybody's cup of tea. A lot of people get real mad at some of the decisions that were made by the Rust creators about formatting. That's fine to be really mad. It won't solve anything. Just follow the official Rust format. It is good enough, and everybody in the community expects to be able to use that format so that they can read your code easily. And everybody is communicating in essentially the same language. It's, just take Rust format suggestions and Clippy's suggestions for the most part, even if you disagree with them, especially when you're getting started. The tools are probably right and you're probably wrong. That sounds harsh, but I think it's reality. So these are Rust variables. Like I say, we have string types. We have integer types. We also have floating point types, which we'll use a little bit in embedded programming because weirdly, our tiny, cheap computer has floating point numbers. Floating point numbers are the kind with decimal points in them, and they have weird special formats that we won't discuss. But I can certainly say or I can say F32, meaning a 32-bit floating point number, or F64, which is a 64-bit floating point number. And that's a perfectly legitimate thing. And you can do math with floating point numbers, etc. Again, you can't mix them. That won't work. Can't add an integer to a float, and the suggested, and there's not even a suggested fix, but there should be. I think into may be sufficient here. Let's find out. Nope. There we go. Now it'll work. Yeah, so we got integer and floating point numbers. We got strings. None of these are very surprising, I think. We also have Booleans. And we have if statements, like you'd expect. And so this, this thing here is the expression. It isn't like C. It doesn't have parentheses around it. It's just the expression. And if that expression is true, then let's make it be something more interesting. Well, we'll do it first this way. This runs fine and prints exactly as we think. We can say this, right? Oops. 6.0 because it's a floating point number. And that works. But of course, we wouldn't normally do that. We'd just say this. And now we've got Booleans and if statements. So, and if statements obviously have else parts. That's fine. You'll notice that in Rust, bodies of control statements are fully bracketed. These curly braces aren't optional. The compiler will not let you leave them out. Even if I, comment all this out. Another style of Rust comment. The compiler is going to refuse. It's going to say, no. You were supposed to have curly brackets there. So this is absolutely required right here. If you want this to compile. All right. So the last thing we'll talk about, and then we'll take a bit of a break while I go refill my coffee and we get a chance to use the restroom and that kind of stuff, is You'll notice that I haven't written any data types anywhere. Rust is a statically strongly typed language. That is, the compiler knows the type of everything, or has to know the type of everything at compile time. And in this case, like I say, the type here really is I32 for this. And right here, the type is F32. So I can actually declare these types like this. This is perfectly legal Rust and is considered decent style if you want to do that. But the thing you should know is that Rust is a little special. I am going to get rid of this. It's uglying up everything. Rust is a little special. If I don't do this, then the compiler does what's called type inference. Type inference is the process of figuring out what type must be here by looking at how it's used. So here you can tell that Y must be a F32 because it's a number that could be an F32 plus a number that definitely is an F32. And so the compiler can figure out that this must be F32, which means that you don't have to write it. And this is all checked at compile time. That's the important thing to understand. This isn't like Python where you'll get a runtime error if the types don't match up. It's at compile time you'll get an error if the types don't match up, even though you didn't write down the types. It's pretty super cool. If I try to make this be right, that looks perfectly innocuous, but it knows that Y is an F32 because it can tell from here. And so it can't be an F64, which it needs here. So we'll get a compile time error, mismatched types. And that's a compile time error. That's the important thing, is that, it fails at compile time. Yeah, we have this recorded. So any stuff you missed, you can come back and get later. Plus, I'll put notes up of what we did. So yeah, the underbar here, by the way, just tells the compiler don't whine about the fact that well, first of all, this should have been 12.0 F64, but it's all fine. And don't whine about the fact that we're not using Z again. Without this, even if I fix this, like this, the compiler's going to be like, yeah, you made this variable Z, but you didn't actually use it. And then it tells you what to do about that. It's like, if you meant to not use this variable, then just do this and it'll shut it up. Yeah, fine. Yeah. So that's compile time type inference, and it's pretty strong. And it means that you can write code without very many explicit types in it and still have the code type checked at compile time. It's super sweet. So I'm going to take 6 minutes until 50 after, and we can take a little break and figure out what we're, while we get ourselves together, and then we'll go on reviewing Rust. What I would like you to do during the break is, if you think we're going too slow or you think you're going too fast, leave a comment, because I can speed up or slow down to match what people need to know for sure. And let me know anything else that would be helpful. I will see you all in 5 minutes or so.
Hello, the build. How you guys doing?
Yes, we can.
How's the training going over there?
Can you hear us? Can you hear us?
Awesome.
It's going on.
How's the training going over there?
It's going nice.
Okay, no issue. Oh, hello, Professor. Are you still there?
Yeah, I'm back.
Okay.
So we'll get going again. What I was about to type in the comments here is I hear people saying I'm going a little too slow. I don't hear anybody saying I'm going too fast. So I'm gonna speed up a little bit. I think a lot of the stuff I covered so far is stuff that we definitely needed to cover. But assuming that everybody's pretty comfortable with what we just said, then we can go quite a bit faster, and maybe we can get through more of the Rust today than we intended. and be ready to start with the actual embedded Rust a little sooner. So yeah. All right. So as you can tell from the fact that main is this function, albeit a special function, Rust has functions. Who knew? And in Rust functions, there is no type inference. You actually have to declare all the types. So here, we'll make this be an I32, and we'll make the result be an I32. And we will make the function return X. Sorry.
Hello. Sorry, we are not seeing your
screen. Oh, sorry, I'm not on the screen again. Yeah, thank you. I do this mistake all the time. Thank you for yelling. I appreciate it. Yeah, let's try that again. So Rust has functions just like you think it does. And, here we have a function called sub3 that takes an argument X. Notice that X has to have its type declared, and the result type of the function has to be declared. That's just a requirement in Rust. There's no type inference except inside the body of functions. And so this thing's going to take an I32, it's going to return an I32, and like its name implies, it's going to return X minus 3. Now, you'll note you might have expected me to write it like this, and indeed, that's legal Rust, but it's not considered good Rust. We'll talk about why here. Well, first of all, I probably should call this... Let's call this somewhere. There we go. Notice the type inference here. It knows that X is an I32 because this 4 is an I32 because X is an I32 here. I can change this actually. I can make it be U64 if I want to, and the compiler will be perfectly happy because the argument to sub3 is a U64, 4 is a U64, life is good. This is legal Rust, but if I ask Clippy about it, it's like, this isn't how we normally write Rust. Remove the return and the semicolon. So let's try that. Does that really work and produce the same answer? It does. Oh, right. It compiles. Does it produce the same answer? Yeah, it really does. Why? Well, because in Rust, blocks have a value. The value of this function body is the last expression. Anything with curly braces is what we call a block. And this block has the value X minus 3 because that's the last expression in the block. This is standard stuff for Rust, and this is always the way you would write this in Rust. A really common mistake to make is this. And you'd think that would work fine, but it does not. Let's see what it says. It says mismatched types, expected U64, found open parentheses, close parentheses. Well, that's gross. What the heck's going on? Well, what's going on is that this is a statement. It's an expression valued statement. After this is an implicit expression, and the implicit expression is the value unit. We read this open parentheses, close parentheses thing as unit, and the unit type is a special type that has only one possible value. That value is also unit and is spelled the same way. So I can write this, and that's a legitimate piece of Rust. But the problem is that here, if the last expression has a unit type and it's supposed to have a U64 type, I get a type error. And I point this out in particular because it's really common to get really confused by this. So I'm just warning you for later. Let's make this be underbar Y so it doesn't whine about it and everything's good. And now we have a perfectly legit Rust program. So every function returns a value. Sometimes it's just the unit value. Like this. And in that case, implicitly, this function returns unit value. It's the same as if I'd written this, except I don't have to. And so if I down here put a 3, then it's going to complain about a type error again. But if I do this, then it returns unit, and all it warns about is print stuff is never used. So we'll stick an underbar in front of it so that it doesn't whine, and we're good to go. So that's Rust functions, pretty much all of it. Obviously, in addition to if statements, Rust has while and for loops. Oh, let's not do that. And let's go. And now, sure enough, x was 2, so we get 0 and then 1. Notice that for loops in Rust are the same as in C. You stop just before Java or Python or whatever. You stop just before the top value, like Python's range operator, for example. So, yeah, that's a completely boring for loop. The interesting thing about Rust's completely boring for loops is that this is what's called a range expression. This is actually not some piece of fixed syntax. That ... is the range operator. And so you can actually, you can actually play games with that to make more complicated expressions. So for example, I can write this to reverse it, and now it'll print these numbers in the opposite order. Rust for loops are pretty weird, and next week when we talk about traits and stuff, we'll talk about some of the weirdness of Rust for loops, but they're really nice to use. They're very not error prone. If I want it to go all the way, by the way, there's also a range operator, an inclusive range operator that looks like this. And so I can actually make it go all the way to the thing if I want to. That's for loops. While loops are just pretty much what you think they are. I'm not really sure. There's a lot of point wasting time on them. The other thing I wanted to say is that if statements in if-else statements in Rust are actually expressions, like question colon in C, I can say something like let Z equals if X is less than 1, 0, else -1. That is absolutely a legitimate thing to write. Notice the semicolon here because this whole if is part of the let statement. And that will work fine. And this is actually a style that's used a lot. Again, notice that these are just the values of these blocks. There's nothing special about them. So it's all pretty regular and all pretty full of joy. kind of things that you want to work kind of work. So that's the basic data types. That's functions. What else were we supposed to do today? Nope. Basic data types, variables, expressions and statements, functions. Yeah. So we've moved a little faster than I actually thought we would, and we have time to do some more stuff. So if people are cool with it, let's go on and do some more stuff. Yeah, you'd like to know how it would fit. Okay, it's good to hear someone say we're moving a little bit fast. Yeah, hopefully after today, you'll go grab the Rust programming language and catch up with some of this stuff if you haven't looked at it before. It's going to be one of those things where, yeah, we're going to do kind of a quick start because we want to get to embedded in a reasonable amount of time. But I'll try to keep the pace reasonable. How does it fit in your job? Well, Rust is a very rapidly growing programming language. People like it. Industry likes it. It's sort of a whole thing at this point that is especially exciting to see its growth. And the place it most obviously fits is in low-level programming. Rust is going into the Linux kernel. Rust is replacing C and C++ in a lot of places where C and C++ are used, or at least is being used for new code in places where it would otherwise be used. And Rust is also being used for high-level things. I teach a whole course, and I'm working on a book right now on Rust web development. The combination of really good compile time checking that catches a lot of errors, really good runtime checking that catches a lot of the rest of the errors, and really powerful tools, really good support and producing programs that run fast in small amounts of memory. That combination is pretty good for a lot of things. And so I don't know what your job actually is, but it's likely to be a job that might benefit from Rust. I write mostly in Rust these days or Python. Those are my two main languages. And I don't write Python if it's more than 50 lines. It's starting to be big enough. I'd rather write in Rust. Hopefully that answers your question. Yeah, let's go back to the screen here. So I think we can just keep going and talk about some of Rust's fancy features, because up until now, this language is cool, but it's just a programming language, right? There's nothing super fancy. I have written C since 1983 or so, and every time I sit down to write C right now, because I think I have to, I try to figure out a way I could do it in Rust instead. I strongly, personally prefer Rust to C for everything that C wants to do. It's just a easier language to write in. It produces, it's much less error prone. It has a lot better tools and libraries. One of the things we will talk about later in this course is Rust's amazing crates.io library ecosystem, which is kind of best of class. And so, yeah, I'm very much a Rust person over C. Obviously, there's a billion trillion lines of legacy C code, and obviously that's not all going to get rewritten in Rust. But for new code, I use Rust. Yeah. So far, we haven't talked much about memory. Yes, I think over time, Rust will mostly supplant, over 20 or 30 years, Rust will mostly supplant C as the embedded language of choice. I'm not positive of that, but it sure looks like it's going that way. for embedded development, Rust is a really nice programming language, and we'll see that in the next few weeks. So yeah, memory. So let's just start a new piece of code. I think I don't want to extend this one anymore. Okay, so Rust has, yeah, I agree with all of those things, comments about C. One place where C is still being used for new code is weird microcontrollers. The new embedded code is weird microcontrollers that Rust doesn't support yet. But that situation's getting better every month now too. So let's take a look at let's take a look at how Rust deals with memory, because we haven't really talked much about memory yet. And obviously in embedded programming, it's a thing. So when I say something like this, you have to understand that we talked before, this is 4 bytes of memory that has to go somewhere to store the value of X. And like in most programming languages, that the place where it stores that is the stack. The stack is a chunk of memory per function that is used to allocate local storage for that function. And because it's in memory like that, I can also see where in what address in the computer's memory it's at. I'm going to write it this way so it's clearer. I think the compiler will take this. Let's find out. Yep. And it says, whoops. Oh, sorry. No, that isn't what I wanted at all. Right. So this says take a reference to X. That is, take the address of X and use that as a thing. But unfortunately, then println actually goes and dereferences it implicitly. So I need to tell println not to do that. Now let's see if I can remember how you do that. I kind of want to say it's this. No. Yes, there we go. So you can tell that value 3 is a 4-byte value living at machine address, that weird hexadecimal number, right? We're going to be working a lot with hexadecimal in embedded. Hexadecimal is just base 16. So the digits of hexadecimal are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And so this C here is worth 13. This 3 is worth 3 times 16. This 7 is worth 7 times 256, and so forth. It's place value just like binary, but with a much larger base. But the magic of hexadecimal is that you can convert it to binary pretty easily. So like I say, C is 13, which is yeah, 8, 4, and 1 is 13. So that's the last digit's that. The other digit's 3. And then the next digit to the left of that is a 7. Like that. And so this is a shorter representation of a very long binary number. The point is, we can convert that to decimal if we must. It's easy enough to do. You use a tool. This is a programming language I wrote a long time ago. And it says, oh, sorry. It's this number. So that's the address in memory where that 3 is living. And these references, like you saw, can be used to, for multiple things to refer to the same value. So now we get to have fun with Rust's so-called borrow checker, which everybody's afraid of, but honestly, I think they're more afraid of it than they need to be. The thing is that it's really easy to make terrible mistakes here in C with pointers, right? These references are kind of like C pointers, right? We can actually give this thing a type like that. This says, oh, this is a reference to a U32. It's super easy to make weird mistakes by messing with the pointers in weird ways in C. Rust doesn't let you make these weird mistakes. And in this case, I might want to change X at this point. By the way, because type inference, I don't actually need this. So like this. So now you might think everything will be cool. We'll change this to 4. So this will print 4, this will print 4, and this will print the address, same address we got before. No, cannot assign twice to immutable variable X. Well, let's make X mutable then. That seems reasonable. Oh, can I assign to X because it is borrowed? And this is the borrow checker kicking in. So Rust's got a rule that there's only a single source of truth, a single so-called owner for any value. And in this case, the value of X is owned by the variable X. Here, X owns that 3. Right here, we borrow that 3. That is, we take a reference to it and we store that in XP. And while that's true, you can't change X. This is just not allowed. There's no way to do it until you get rid of that pointer. If I print this and then get rid of that pointer, which you can do with Rust's drop. I can get rid of that pointer and make it go away. And now the compiler is cool with it, because once X isn't borrowed anymore, then you can change it all you want. Oops, warning calls. Oh, yeah, no, it's warning that. Oh. Oh, okay. I don't actually have to explicitly drop it here because the borrow checker will still let it work, I guess. Let's just get rid of this. Right. So the borrow checker is fine with this. It says once you're not using this pointer anymore, then this assignment works absolutely fine. I think you're right about Rust, but we'll see. This pointer is this works absolutely fine because I don't ever use this borrowed value again, and because of that, then it's not borrowed anymore, and now I can change it. This is the borrow checker in action. By the way, I can borrow it multiple times. That's perfectly fine. And in fact, I can borrow it by doing this, whatever I want to do. And all these things work. I'm going to get, yeah, it's fine. And all of these should print the same thing. Like that, and everybody's perfectly happy. So I can have multiple things borrowing the same owned value, but the borrow here keeps the value from changing underneath. From now until all the borrows are gone, X is sort of frozen in place. So that's borrowing. There's also mutable borrowing. So I can absolutely say something like, since X is mutable, I can say let XP equals, and I'm going to quit writing the type. Maybe now I'll write it here. Remember, these types are optional. Type inference will get them all. But I can say this. Now I've borrowed X mutably. That is, I have a pointer I can write through. Again, these are like C pointers, except with more protections, more constraints. And so now I have a pointer I can write to. And that's fine. I can now store through that pointer in exactly the same way I did before, I would in C. And then I can do this. And the funny part here is this won't compile. Let's watch. Cannot borrow X as immutable because it is also borrowed as mutable. Okay, well, there's that. Oh. It hasn't figured out that it's no longer mutably borrowed. Right. No. Sorry. Right. Sorry. This error message is very confusing. What it's telling you is that I can't access X at all right now because I have a mutable. I've borrowed it mutably. I've borrowed it exclusively. And because of that, I can't do this. If I just do this, everything's great. And it's like, yeah, sure, that's a thing. But until I release this, I can't say let Y equals X plus 1. That's not allowed. I can't even let Z equals and X, right? Neither of those are allowed. The only thing that's allowed to access that location right now is this mutable, this exclusive pointer. So this won't work. And even if I do this, this won't work. So those are the rules. They're the rules that are like the rules in databases for shared and exclusive access, right? You can read lock something in a database or read lock something with a read write lock in Rust or whatever, and that allows everybody to be able to read, but nobody can write during that time. And then you can write lock, which means that only the person who owns the write lock can write or read the thing until you release the write lock. This is one of the more complicated concepts in Rust, and a lot of people struggle over it a lot, but mostly they struggle over it because they run into it and panic. This kind of message is super scary because it doesn't correspond to anything you understand. And the trick when you run into these borrow check errors, which we'll run into throughout this whole series, is first of all, to not panic. Second of all, to reason about how borrowing works in Rust and try to figure out what's going on. And sometimes that's really hard. Sometimes you're like very confused. After 10 years of programming in Rust, sometimes I'm very confused about a borrow checker error. And what I do is stop and go away and come back and see if I can spot it. But if I still can't, I use one of Rust's superpowers. And what is that Rust superpower? It's Rust community, which is just amazing. You can get on the Rust language Zulip. You can get on the Rust Reddit if you're still a Redditor, which I'm not anymore. You can get on the Rust Engine Zulip in our channel. There's a million places you can ask questions for Rust stuff. When you get stuck with something like a borrow check error and just can't figure it out, go ask somebody. Don't be shy about asking questions. The reason I call the Rust community a superpower is that the Rust community is one of the most friendly, helpful, caring groups of people around any programming language I've ever seen. If you're used to toxic programming language communities, and you may well be, know that we work really hard in the Rust project and with the Rust Foundation to make that not a thing. We have a serious code of conduct and we mean it. But more than that, we just have a bunch of people who want to help each other and have fun. So, obviously there is a point beyond which, you should figure stuff out for yourself, but it's a lot lower than you think. People are happy to help you. People are happy to share stuff. People are happy to help you figure stuff out. And that's the way you really fight the borrow checker, is you don't fight the borrow checker alone. You fight it with a friend beyond a certain point. The AIs are actually all now pretty decent too. I use Google Gemini mostly. And if you ask Google Gemini about a borrow checker error, it can probably help you with it more than you think. So that's a good backstop. But, nothing wrong with asking a human being. Absolutely nothing wrong with that. So, what was our next topic here? Let's go back here. Go find what our next topic was supposed to be. Oops. Structs and enums, hooray! So Rust has structured data types, just like any language, modern language does, except Python. Yeah, it's linked off the front page of the Rust book, I think. That's the Brown book, I guess. Oh, no, this is a video series. Yeah. Yeah, there's absolutely other things out there. If you go to rustedu.org, we have a very out-of-date list of resources. I would love to have somebody help us put better ones up. But yeah, there's a lot of stuff out there for beginning Rust. Another thing I really like that I should have probably put in the links on the top is if you're looking for just exercises to screw around with, I'm kind of a fan of Exorcism's Rust track. It's okay and is definitely one that I've worked through most of and can vouch for, reasonable quality for the exercises. Let me get a link to that. Exorcism.org. Tracks Rust. That's it. Yeah, this is a good set of sort of generic exercises. They aren't Rust specific, but they are reasonably well done and reasonably usable and provide for me a good starting place. The other thing that people like a lot is Rustlings. I've had mixed success with Rustlings, but I should put it up here because a lot of people like it. Rustlings is another tutorial of Rust with exercises that's an official project of the Rust programming language. So that's another thing you can do to learn Rust real quick. It's got tooling, and you sort of work along with the exercises and that sort of thing. I'm just now realizing we are out of time. Are we not? I think this is the scheduled stop time for today. In fact, I'm a minute over, and I apologize. Let's call it good. And I really look forward to talking to you on the Rust Zulip over the next couple of days. And I really look forward to talking to you here again on Wednesday for the next thing. Yeah, HackerRank has some stuff. I haven't looked at it much. Cool. Thanks everybody. I hope this was useful. I hope the everything's as good as it can be. Definitely give me feedback. I am more than happy to adjust. And I really appreciate the people who made comments today. That was really, and had questions and that kind of thing. I really want this to be a conversation. I'm very down for that. All right. Take care.
Okay. Thank you very much, Professor Brad. Thank you for the amazing class. We enjoy having you. And then for everyone that is tuning in, we expect to see you same time by Wednesday for the next class. And for further knowledge, the class is going to run for 4 weeks, and the course outline is on the GitHub, which is current. I will also share with you guys. And also from the GitHub, you can have the you can see the link to join the Zulip. It will be nice having you guys on the Zulip where you can discuss more, you can meet more people, you can discuss more. And then for the class is going to run, so you are going to see the outline of how the class is going to run till when we start. So thank you very much everyone for joining, and thank you. I'm sorry for taking 2 minutes extra of your time. God bless you. Thank you for having you, Professor Brad, and see you next time.
See you from RustConf on Wednesday. Look forward to it.
Thank you. Bye-bye.
Thank you. Bye.
Okay, thank you, Build, for having you. Bye-bye. See you next time.
The glass is good.
Exit StreamYard.
Okay.
Stay in the studio. I'm supposed to stay in the studio until my recordings are uploaded, it looks like. So.
Yeah. Please just stay on studio so your recording is uploaded. I've ended.
All right.